another one of my high quality drawings and videos, but the theory's sound, even if the production quality is not so great. Anyway, been asked again about plate loading via a combi, and I've done a couple of little sketches here. So one of system for plate loading via a combi on an open vented cylinder. So very simple process. We basically on an unvented one, you've got to use the cylinder connections to decouple. So don't pipe up the same way as you would an unvented cylinder. But basically, a top tapping here, or adding an Essex flange, and an additional tapping at the bottom, or an Essex flange at the bottom would also work. Normal open vented fixture here with your tap. So basically you take a flow off the bottom through a bronze pump and non-return valve through your combi and back again, and that's on a timer via the cylinder stat to the pump. So basically anytime you're calling for water, or the stat sees a fall in temperature during an unprogrammed time, it will run the bronze pump through the non-return valve, fire up the combi and load the cylinder. The people getting confused about mains pressure through the combi. Obviously the system side would possibly need to be pressurized, could be what they call semi-sealed, or pressurized, but the hot water side doesn't need to be. It just needs to have enough motive force through the combi to operate the flow switch and to fire up the boiler, and also of course it's got to provide adequate flow through the combi to get some function from it. So no reason at all not to do that design as far as I can see. Now I've never done it and I've never seen this done. This is purely theoretical and something I've sketched up. So if anyone can see any legitimate reason not to do this, do let me know, but I can't see any reason not to do it. This is one that has been done a few times and I've done it myself. And of course the issue with this is whether you've got approval for G3 for running this system on an unvented cylinder. But basically on an unvented, obviously I've missed out the controls line on the inlet to the cylinder. What we're interested in is on this one we can connect into the same inlet point. We don't need to add an additional tapping on the cylinder. Come in the bottom for the feed in, or via the pump to go round, and we can come in either alternatively from a tapping if one's available for a bronze circuit, or we can come in the top close to the cylinder, and that's our draw off. Now the advantage of the unvented system is that even if the pump isn't running, when we run a tap we will develop a delta P across these two pipes here from the incoming main, and so we will get flow through this system at the same time as running this tap, and so we'll get some combi action going on and we'll get the tap drawing, and of course very quickly we'll see the temperature drop at the cylinder stat anyway, which will fire up this pump. So you'll be getting your pump supply through to the tap, and your normal cylinder displacement going on. So going back to this one, obviously the same thing can happen when the pipe stat sees a fall in temperature, it will fire up the pump. But in this case we've got this low pressure zone, like a low loss header, so there's no pressure difference between these two pipes here. So this will have a tendency to load this cylinder. The water can get drawn off and the water can get drawn in this way, but there'll be no induced pressure from the pump onto our outlet. There'll be no pressure induced on the expansion or on the inlet to the cylinder, very neatly due to that principle of load EP. So I hope that explains it. Very simple. I don't think it needs much more explanation than that. I think people imagine it's going to be very complicated, but it's not. It is very simple. I will put this up on my YouTube channel, however amateur it might be. And if you aren't already subscribed to my YouTube channel, please do so. And don't forget to give me a few likes.